I'm Don Toporowski, and I'm the CEO of ReThink Mining, where we're always on the hunt for new technologies to tackle the toughest challenges in mining. And that's what we're doing here today. I have Thomas Gustavsson, the CEO and co-founder of Hypex Bio, along with his colleague Blake Morgan, the Chief Strategy Officer for the company. We're here to talk about alternative explosives. Welcome to the studio and to Toronto, you guys.
Thank you.
Thank you very much.
Great to have you here in the studio. Since I've been working in mining, which is not that long, your technology is one of the most interesting things I've come across. And what got me even more interested was we brought all of the members of ReThink Mining together over the last couple months to talk about their priorities. What do they want to focus on for new technology? What are their main areas of interests? What would they like to work on together in collaborative projects? I was a little shocked when they brought up alternative explosives because I hadn't really been paying attention to that. I didn't know anything about it. But they specifically said, this is a thing we're all interested in. We're kind of curious about it. We don't all want to repeat the exploration of it. Can you give us a hand? And the only company name they brought up was yours. And they said, look at these guys specifically. So I'm so glad you're here in Toronto to talk to us. I understand you have a whole tour of Canada coming up, but looking forward to exploring these things with you. Tell us first, what's the issue with explosives in mining? Why does it need to change?
Oh, thank you so much for having us here, first, Don. It's always good to hear the interest from the mining market, and that feedback is very interesting. We see that the innovation in the explosive space is very limited, and so on and so forth. But to your question, it's important to recognize that the most energy effective way of moving rock, which we're doing in mining every day at scale, is by drilling and blasting. We drill a hole in the rock, we fill it with explosives, we detonate the explosives, generating gas, and we move the rock. Traditionally, this has been done since black powder, and then obviously nitroglycerin. We have dynamite, which you mentioned as well. But in the 40s, 50s, after the war, we moved over to other chemicals. And the predominant chemical that was selected for various reasons was ammonium nitrate. It started with ammonium nitrate basically in powder form combined with oils, normally diesel and other fuel oils, referred to as ANFO. And then in the 80s, 90s, we moved over to something called emulsions. But they're all based on ammonium nitrate. And ammonium nitrate is basically ammonia, which we probably know about ammonia. It's a very smelly liquid, which we combine with nitric acid, forming a salt called ammonium nitrate, which generates a lot of oxygen when you burn it. And we use this to build an explosive because you need oxygen and you need fuel. And this is the explosive we use globally. The absolute majority of explosives today, 99% in excess, is ammonium nitrate. And when you use ammonium nitrate, you get a lot of issues, operational issues, mainly stemming from contaminants in water to toxic gas. But you also get strategic problems. You get supply chain problems because the production of ammonium nitrate is very controlled. There's few players producing ammonium nitrate. In Europe, for instance, there's only one player producing technical ammonium nitrate, that is Norwegian Yara. So the entire mining industry is dependent on this supply chain. And you have one supplier in Europe, which is slightly scary, And then you also get other issues, lately over the last couple of decades, emissions have become more and more important for the mining industry. And producing ammonium nitrate is very energy intensive. We use, the normal process is the Haber-Bosch process to produce ammonia, which basically takes fossil energy, natural gas, other fossil fuels, condense hydrogen from that, bind it with atmospheric nitrogen to build ammonium nitrate. And then, obviously, because we use these fossil energy sources, it's very dirty. But then also when we detonate ammonium nitrate emulsions or ANFO, we get a lot of toxic gases, a lot of greenhouse gases.
So I was shocked to hear that by changing the explosive, you could actually reduce greenhouse gas emissions from mining. Tell us about the impact that you could make specifically on GHG emissions.
So what we have done is tried to replace ammonium nitrate as the primary component in mining explosives with hydrogen peroxide. which is a chemical that's much less energy intensive to produce, and also eliminates many of the issues with toxic gases and toxic residues in water when using explosives. But particularly when it comes to greenhouse gas emissions, compared with traditional explosives, our explosives can reduce emissions by over 90%. And because explosives are such a significant component in emissions for mining operations in general, we see that for large-scale mining operators, shifting from conventional explosives, so based on ammonium nitrate, to our hydrogen peroxide explosives have the potential to reduce total emissions by between 5 and 12%.
Yeah, that was amazing to me. And what about the ventilation? So if I switch to an explosive like yours, can I have less ventilation, run it less often, save energy? What kind of effect could it have on that?
So I think that's a very, very important question, because that's one of our main value drivers with this technology. When you detonate conventional explosives, you get two categories of toxic gas. The first toxic gas you get is nitrate oxides. It's a very smelly, very dangerous gas. And the other gas you get is carbon monoxide. Both of those gases you need to take into account. Obviously, because we don't use any nitrates in our explosives, we cannot form the nitrate oxide gases. But the carbon monoxide we do get, but at significantly lower levels. And in fact, we have proven in operations, in real live operations, mainly in tunneling, that combined with other means and obviously optimization of the drill pattern and the way you use explosives, we can significantly reduce the re-entry time and the ventilation need. So from my perspective, combining, for instance, electrification, when you go deeper underground with our explosives, have the potential of offering what we call continuous mining, drilling and blasting on shift, continuous.
So if you were to take an existing mine, you're stuck with the ventilation system you have. Would you get savings from running it less, or you're saying the economic advantage comes from mining more continuously?
There's a couple of answers to that question. The first thing is obviously you need electricity to run your ventilation. And as you go deeper, obviously when you have mined your ore, you need to progress your tunneling, which means you need to rebuild your ventilation. You need to continuously move it as you move forward with your development. So there's a couple of components. The first thing is obviously running less energy through your fans. Then maybe potentially, which we, to be honest, don't know yet, maybe lower the requirement of building the sizing of the ventilation as a whole.
In terms of volume of airflow.
Volume of airflow.
Yeah.
But I also think it's very important to recognize that mining does not only involve blasting in a very controlled way at a set schedule. Normally mining involves reblasting, secondary blasting of things that didn't really work out, big boulders that you need to take care of. And if you have toxic explosives, you need to take care of those reblasts as a part of your production, which means that it takes time for your production. So can you do complementary blasting on shift to make sure that when you do your production blasting that actually advances according to plan is a tremendous advantage.
How does the products of the combustion, these gases, how do they compare to the gases from the diesel engines underground in terms of offensiveness? I mean, which one is a greater offender, diesel fumes or fumes from explosives?
Because you have, obviously the fleet of mechanical equipment you have underground today is predominantly run by diesel. So just the sheer scale of diesel you're burning underground means that diesel is the biggest problem. But we also know that a lot of mines are going into electrified solutions for various reasons. And when that shift really happens at scale, then the diesel problem goes away.
But also I think it's important to talk about peaks of toxic gases. So when you are running vehicles underground, you're getting low amounts continuously. But while running diesel vehicles, it's okay to have employees in the mine. But when you are blasting, you get a huge peak of toxic gases. And because of that, you have to essentially bring everyone out of the mine usually. And it's avoiding those high peaks that our explosives can really provide a lot of operational savings.
Okay. And what about the effect on water? How do traditional explosives affect water? And
so when blasting with ammonium nitrate-based explosives, there are two main challenges. You get nitrate pollution in mine water, as well as ammonia that is also ends up in the water and is released into the environment unless sufficient cleaning of mine water happens. And doing so is a challenge for mining companies on multiple levels. It's an ongoing operational challenge to clean the water sufficiently. And when that doesn't happen in a sufficiently effective way to meet local regulations, it can result in fines. But also it can be a strategic challenge in terms of expanding production or opening new mines. For example, when you expand production, you have to do more drilling and blasting, which means more nitrates and more ammonia in water. And that can result in permitting issues or challenges getting new permits. So our explosives can really contribute both in terms of reducing operational costs for cleaning water for nitrates, for example, as well as capital investments in additional capacity for water cleaning. But it can also ease permitting processes and reduce time frames for receiving new permits.
do you eliminate the environmental damage, or do you just change it or make it less?
Well, I think we can look
In
at...
terms of the air and the water.
Yeah, because you can divide the environmental impact into two main categories. You have the local impact, which is toxic gases and water pollutants, and then you have the global impact, which is around greenhouse gases. And if we focus on that local impact, we eliminate the primary toxic gases as well as the problems with nitrate runoff and ammonium in water. So that's entirely eliminated because our explosives don't have nitrates or ammonium at all. We do, as Thomas mentioned, get some carbon monoxide, which is toxic. You don't want to breathe in that. But it's much reduced compared with conventional explosives.
So is this like a secret that you guys have you just discovered it, or you're keeping it? Why does no one mention hydrogen peroxide can be used in an explosive?
Well, we've known for many decades, a long time, that hydrogen peroxide can be used to produce explosives. But hydrogen peroxide is a reactive, sensitive chemical, which makes it difficult to create sufficiently stable solutions to make explosives that are reasonable to use in operational environments. So it's been something that hasn't been done historically. There has been no commercial explosives based on hydrogen peroxide. That is something that is new. And what we have achieved is sufficiently stabilizing a hydrogen peroxide emulsion to make it safe and efficient, effective to use in commercial mining operations.
What I worry about is that you guys make this great progress. Everyone accepts it. You start changing mining for the better, taking away those traditional explosives, getting yours in there, making it cleaner, better, more efficient, cheaper. And then the big players in mining explosives say, thank you very much, and they start making it. How are you protected against being crushed by the giants in this business?
It's a very relevant question, but before we answer that, we need to understand the dynamics of the current market. Because ammonium nitrate has been used as the predominant raw material, it means that the bigger players are completely integrated into the supply, production, and dealing with this chemical. So they have vast capital and interest and know-how invested in traditional technology. So switching for them is a tremendous decision. You can compare it with the automotive industry when they have to move platform from combustion engines to electrical engine. It's a tremendous shift. This doesn't really answer your question, but we're getting there, right? So it is it's a transition cost they need to consider. And that is obviously protecting us so far. But that is also really a question of scale. If we scale, it becomes existential eventually, right? But our way of dealing with that is that we have the traditional ways of dealing with it, which is IP protection, patents, know-how, and so on and so forth. My personal belief is that the best way to manage that is just to be better. to continually advance, to service customer better, and so on and so on. But the other component that is we are building a technology platform, a platform that we have specifically designed to be integrated into existing infrastructure. From my perspective, it's better to partner with us than to compete. Outside of the Nordics, where we operate ourselves, we want to partner. Now, we already have partners internationally, but I foresee that partner, that type of partnership is growing from suppliers to end users. We want to be a technology provider that can help end customers, distributors, existing explosives providers to become greener by integrating our platform.
One of the first things I learned when I started working in mining was how dominant these explosive companies were. I guess there's two of them.
There's several large explosive providers. There's two that are the largest, but there's a small number of very large explosive providers around the world.
A small number of very large explosive providers.
Yeah.
And what it seemed like to me was we were talking about different technologies to drill the holes and, charge them. And it seemed really important to work closely with these explosive providers because they were so entrenched. It seemed like in a mine, there was very little opportunity for innovation or to try new things or new suppliers. How can you persuade a mine that is so entrenched with a traditional explosive provider to find a space for you to prove your technology? How can that even happen?
It's a very good question. Our approach has been that from the very beginning, we have tried to work as closely as possible with mining companies and other end users of explosives to really develop this and test this in real operational environments. And I think Thomas can talk a little bit about what we've done historically in order to get that foot in the door and really start using our technology in real life applications.
Yeah, foot in the door. That's why I know. How do you get your foot in the door? Because it seems impossible.
It's taken 20 years. No, but according to my experience is that dealing with explosives is at the core of mining. And if you're at the core of mining, you're in production, which is the holiest of holiest. You don't mess with production. And this is the core of the question. So before you even talk to a mine, you need to have done your homework. You need to understand, is it worth it for them? You have to define the value. Where do you offer something that really addresses their issues? That's the first thing. The second thing you need to do is you need to have laboratories. You have to done all of the testing. Everything you can do before you come to the mine needs to be done. You need to be in a place where you can say, we've done everything we can to prove that this works. We tick all the boxes, but now we need to take it to the mine. And then you just need, you need somebody who is open enough to give you a chance. And in our case, it was Boliden Minerals who gave us the chance to trial this in one of their mines. And when you have that chance, you have to really custodian that. So you take small steps, you're in their mine, you prove to them, their operational teams, to the mine manager, to the strategic teams, one step at a time that you can do it, until you come to the point where it really matters when you charge in production. There's a lot of things you can do in a mine before you go into production. Everything from detonating steel tubes to blast a couple of rocks to build confidence. But confidence takes time to build. And we do it step by step until you come to production. So that's how we penetrate the market at small scale. But when we have that case, we need to scale the case. So what we have done is that we have developed a strategy to do that, customer penetration approach for everyone. We say, we're going to hold your hand. We're going to do all of this in our laboratories to prove that it works. We're going to take your requirements. We're going to make sure that we prove, practically that we can do this. And then you build credibility slowly. But it takes time and capital.
Yeah, it's a stepwise approach that we've seen really work with partners like Boliden and is suitable for us to engage with much larger organizations. We're a small company and we need to work well with very large companies. So we have this stepwise project-based approach that allows us to build confidence.
So there's a few things you could do. Blast this, blast that. That's not at the face, not in the main production. But how do they find a space for you to work beside what's going on there in the regular production? Like what sorts of things?
I mean, everything is not ore. It depends on what mine it is. Some mines are more pressed than others. But normally in a mine, you always have some space of drilling a couple of holes somewhere in the mine where it's not production critical. But it really means you have to take what you get. You have to be there at the mine, you have to be with production, be with the planning, and ask, hey guys, is there any chance we can take a blast today? Is there any chance we can do something? And then you have to be vigilant. And when the opportunity arises, you have to be there, you have to be ready, you have to get it done. And when you get the chance, you have to make sure that it works. That's crucial, right?
So tell me about the logistics involved with explosives. What exactly would you have to have in place so that a mine could feel confident there's going to be no interruption to production? What sort of equipment and logistics? Is it a big deal?
It's crucial, obviously. I mean, so commercial explosives today are obviously produced. Depending on the setup, it can be a centralized production where it's produced off-site and delivered to site in tanks, normally by truck or by rail. For some mines, the production happens at the mine on site, but the principle is the same. Obviously, you need to produce the main explosive component. For emulsions, it's normally non-sensitized emulsion. I'm going to get to that later. Then you need to transport that emulsion to site and store it on site, and you have to have sufficient storage to make sure that the mine can manage over some time in the case you have supply disruptions. So you need tanks, you need transfer systems that can transfer the products from the various tanks. And remember, you're working with energetic materials, which means that all of these systems need to be monitored. They need to, comply to safety standards and so on and so forth. But then you also have what we call delivery systems. You need what we call charging units that takes the emulsion and adds things to it and put it in the hole. On surface, you have big trucks that adds various chemicals, sensitize it, you fill it in the hole. We call them MEMUs. It's an abbreviation for mobile explosives manufacturing units. Underground, you have underground charging units. All of these equipment is complex, electromechanical equipment that breaks. A mine is a harsh environment. Things break all the time, right? So you have to have a supply chain, spare parts, mechanics that can go in and fix the problems very, very quickly, because the blaster, the miner there at the site, if it doesn't work, it's a critical condition. You need to be there right there.
So do you think when the members of ReThink Mining told us they want to explore it together, is it possible that they were thinking that to do it properly in a mine is a pretty substantial investment and fairly complex, and that it would be better if they worked at a single mine together and all shared costs and effort?
Yes and no. It depends what they mean by significant investment. You have to look at it in contrast on value versus investment, but everything in mining is expensive. From my perspective, relatively speaking, I don't think this is a significant investment. I think we can get far with reasonably low capital requirements. But it depends on what you mean with significant. Yeah. So, another important topic is every mine is different. I think it's very good to start at one mine and to build credibility from there, but you're likely going to end up in a situation where mine's going to say, yeah, but our conditions are slightly different, so we have to do it in our place as well. What I think is valuable is in-country concept proof. Mm-hmm. Because now we have proved this in Northern Europe. We need to do the same in other regions. We have to have a foothold and a proof of concept in North America, maybe Canada, maybe US and Australia. Because if we have that, we have overcome regulatory hurdles, we have overcome some culture hurdles, organizational hurdles, which are things that are not really directly connected to the supply chain, but essential to get it done.
Yeah, when I looked at your website, I'd made an assumption that your company wasn't, that big. But when I look at your website, I think it was, there was a lot of locations where you were doing stuff. Mm. So you can't just take your explosive, put it on a ship and ship it somewhere. You have to have some kind of infrastructure locally. Like if you went to Australia or North America or South America, what do you have to do in that country to properly supply?
Yeah, well, the first step is really around the regulatory environment. So we need to certify our products, our technology, production methods in every new country that we enter. And we have done that in the EU, in the European context. And so we have a footprint throughout multiple European countries. And right now we're actually in the process of working on that for Canada and Australia. Mm-hmm. We're actually currently building an emulsion production facility together with a partner here in Canada. So it's both the securing the regulatory side of things, getting permissions both for production and transport, and then also building some local infrastructure, because we can definitely transport smaller quantities across international borders, but for larger scale production and even larger scale tests, we do want to have in-country production. And there we, as Thomas mentioned, we often work with local partners, so explosive providers or end users even in a market that want to adopt our technology and work with us to build local production.
Let me unpack that a little more. I just want to comment. To get value, you need to do some scale, because a mine normally, as does its work, it means that we have to charge multiple blasts, and then we're talking tonnage. It's not a couple of 100 kilograms, it's many, many tons of explosives you need to produce. So in order to do that, you need some sort of reliable industrial production. And we do two types of plants, really. We do industrial plants, which are centralized plants for scale. And then we do pilot plants, which are small miniature plants that we can place on a mine to run pilot production at small scale, but it's sufficient for a trial, right? And that's proven to be very successful.
What's like the journey that you take the customer on or the mine on to make them feel comfortable about the safety? How does it usually go? Like, how do you get them there to say, okay, I'm not as worried as I used to be?
I think the first thing is to accept and acknowledge that there's a concern, and accept and acknowledge that safety is at the core. You cannot compromise with it. And you're working with people. People are normally emotionally driven. So you need to deal with the social, psychological situation of these things. And from my knowledge, the best thing is to find people at small scale, a handful of people, and then you give them the complete transparency, everything you've done, and then you show them, bring them on, make some emotions, and ask them, what do you want to see? What's your concerns? And then we do experiments that disprove their concerns. And we say, okay, if this happens, what are the consequences and how do we deal with it? You need to recognize that mining is tough. It's dangerous. You work with, a lot of very risky operational procedures every day, but there are procedures for it, So if you respect the procedures, you can deal with everything safely. And this is the same case. So learning the procedures, understanding why they're there, but also allowing them to test, feel, try to overcome that psychological feeling.
Yeah. In terms of building that confidence and trust, when we engage with new partners and new customers, it really usually starts off by just showing pictures and videos from existing customers and trials we've done. And then the next step is often that we bring representatives from those partners and customers to our sites, for example, in Scandinavia, show them test blasts. They can even charge rounds themselves. And that hands-on experience is really key in terms of building that more emotional confidence. But then we do have this stepwise project approach that allows the organization as a whole to build up confidence and trust. Start off by looking at a business case, then feasibility, looking at the exact conditions of the mine or mining sites that we're discussing, doing lab scale testing, and then moving on from lab scale testing to initial trialing, and in each step having specific targets, goals, and metrics that we measure and follow up on, and then having a gateway to move to the next step.
So tell me one more time about the financial case. So when I looked at it the first few times, I thought, this is a slam dunk. I'm going to reduce greenhouse gases. I'm going to improve the quality of water coming out of the mine. I'm going to reduce ventilation cost. What about like the cost of using the product itself in terms of the infrastructure that has to be put in place and the daily use of the material? How does that compare to traditional explosives?
I think it's important to understand that there's actually a difference between the price of explosives and the costs for using explosives. So ammonium nitrate-based explosives that we've used since the 70s, it's a very mature technology and essentially sold as a commodity. There's a price per ton that mining companies pay. But that only represents a portion of the cost of using explosives. As we've discussed, there's costs related to water cleaning as a direct result of using explosives. There's ventilation costs and operational costs from downtime necessary by using explosives. And so what we seek to do is to reduce the cost of using explosives as a whole by offering these operational advantages. And that allows us a means for the scale that we have. The price for our explosives is higher than traditional explosives. But because that's only a small component of the cost, we're able to justify that and offer significant cost savings and operational improvements.
Yeah, our
to
productivity
the mining
gains.
industry. Exactly.
If you were to consider what the members of ReThink Mining could do for you, 20 different mining companies around the world, and they were willing to lend you a hand to advance your technology, make it go faster, help you succeed, what are the specific things that they could do to help you?
The first thing they can do is talk to us, answer our questions in terms of what's important for them. We need to understand what the value is for them. We will ask them questions in terms of water stewardship, emission strategies, and what do they need? I mean, the problem statement. Before we can solve everything, we need to define the problem. So that's the first thing, feedback, communication. The second thing is basically designing a joint roadmap. Let's say we can agree on a problem statement and we can say that it's likely we can solve it. Then it's commitment. We need to agree on a roadmap. How do we together take it from where we are today to a real life scenario where we can benefit, reap, what we sow? And then obviously our structure comes in. Feasibility studies. We need to define, is this realistic to do and what is it going to cost? And when we have that, a commitment, a financial commitment to support us to do it in a partnership. And vice versa, we will commit to obviously deliver this, based on the requirements to these consortiums as well.
You're on your way to Sudbury and Ottawa in Canada to try to make some progress in Canada. In 3 days, I'm on my way to Sweden. I'm hoping I'm going to be able to check out your facilities there and report back to our members what I saw so that we can fulfill their request to investigate exactly what you guys are up to. And I think we made a lot of progress today. So thanks a lot for meeting us in Toronto and spending your time in Canada to try to make Canadian mining better at the same time.
Excellent.
Thank you, Don.
So much.